So it feels weird giving a video on averages because it's like, what is there to teach about an average, right? And if I asked you what an average is, you can probably give me the straightforward formula that our average is equal to the sum of all our individual components of a set, from I equals, we'll go to 0 to n, divided by the number in the set. Now, this has served us very well historically in the courses we've been taking, but we kind of need to approach this from a new standpoint. And what I mean is that this is true, but there's more nuance to it than we had before. So think back to when you were first learning how to use the periodic table, right? Saw a bunch of elements, you're like, oh, well, it just tells me the weights and atomic numbers. But now you kind of got that intuition to sit back and say, well, it tells me SPDF, it tells me all this other nuanced information. Averages are the same way. So yeah, you can take this approach, but let's consider a few things. Let's consider a population average versus a sample average. So what do we mean by population? Let's consider average heights, and let's consider the average heights of all students on a campus. So let's represent this with a set of X. This will be our big bold X. So X here is the set of all students of all student heights. Now, we can calculate an average based on this, and when we look at the average value of that data set, we're going to end up getting mu. So mu here is a true population average. It is the actual average of the population. We didn't have to do anything other than do a calculation for it. So how is that different than a sample? Well, maybe it's not feasible to look at the heights of all students. So what we do is you say that we're going to take a little subset. We're going to call this X1. And X is a subset of randomly selected students within the general population. So this is our subset of students. Well, we can take an average of this subset, but we're using the average here to imply or extrapolate what it is to the average population. Now, if we're randomly selecting students and we randomly select enough, it's probably reasonable here to assume that we're going to get close to the actual average. So yeah, if I'm selecting from the football team or the basketball team versus, I don't know, gymnastics teams, I'm probably not going to be getting a good average of this to estimate this. But if I do truly and honestly randomly sample students across campus, especially if I do it for a lot of students, it's fair to say that this will approximate this, but it's not actually equal to the average. And so there's two things that happen here. One, we are going to be approximating, when we take this average, we're going to be approximating the general population using it. But the second is that we no longer represent this with a mu. The average of the X1 set is actually equal to X bar. And we're going to do one other thing here is that we're going to lose a degree of freedom. So up here, our degrees of freedom, DOFs, are going to be however big the student set is. Here, our degree of freedom is n minus 1. So why would I lose a degree of freedom? Well, here's the thing. The average of a true complete population is not an estimate, it's an actual number. And so it's a property of the set. Here, we use the average to approximate, and in fact, we use it to more or less, we're going to say interpolate here. Extrapolate's also not the right word, but because we randomly sampled a bigger set, we're pretty sure we're not like sitting on extremes, but we're also not 100% confident that we're like capturing all the information. So we lose the degree of freedom here to reflect the fact that X here is an estimate of the total sets. So already this should start changing how you're thinking about it. When you're taking an average, are you taking an average of the complete population or the subset of the population? If you're taking the average of the complete population, then yes, you can still think about it this way. This is correct. But if you're taking an average of a subset of a population, for whatever reason you're not able to measure the full population, and you're using that to estimate the average of the larger complete set, one, you're going to lose a degree of freedom because you are estimating. You're not actually looking at the true average, you're looking at an estimate of the average. And two, this average, while it should be close to it, and we'll approach it as this set begins to encompass all the data points in this set, it's still not correct. And we need to put kind of qualifiers on that answer. So that's the first thing we're going to change about looking at averages. Talk about in the next video what the average is physically telling us about our data set.